Friday the 9th, 2 days before half moon. Let's go have a look at Canyon Mountain, get a sense of how clear the atmosphere is of smoke. I'm going to zoom in. That's not too bad. Not good, but it isn't too bad. It's better than it's been. Of course, the moon will be a factor this evening. 5-day moon. About to set up the observatory. Oops, everything has to be unlocked. Okay, well, let's leave it at that for the time being. Anyway, have no idea what we're going to be observing this evening. In terms of the sky, you can see it looks a little thick with smoke up there. We're not seeing blue, perhaps hints of it. This is the weekend of the Grant County Fair here in John Day, Oregon. You'll probably hear music in the background throughout the evening, and not just my own music. Anyway, so we'll see what we can turn up, come up with some ideas for the observing, and take it from there. Amazingly, even though it's a 5-day moon, the moon is so far south, given the season, that it really isn't a factor tonight in terms of the sky. In fact, it's hidden back behind the mountains, although it'll still throw a little bit of light up into the sky. I think we're actually getting more light from the fairgrounds that are off to the northeast of here. Anyway, we're looking at Lunacy, the brightest star in Sagittarius. I'm going to set up the parameters here for the evening's viewing. Stepping through it, we'll go to standard parameters. I have no particular plan in place for the evening. However, I guess we'll start with a well-known Messier 22 and get a view of what it looks like. It's a good starting point for the evening. Save it out. And watch as Lunacy glows brighter and brighter, and the background screen also gets brighter and brighter, both based on the fact that the settings are so sensitive right now at 128 flood, 42 decibels auto gain, and also the factor there is dust from smoke in the atmosphere from fires that now have been going on at Eastern Oregon for more than 3 weeks, although there's a chance things will start clearing up some, but I'm only speculating because things looked a little better this day. Here we're going to watch as Messier 22 globular cluster begins to develop on the screen. It is almost beautifully, perfectly culminating to the south. I'll give you the data on it so we can get an idea how far above the horizon it is anyway. Okay, Messier 22's globular cluster, of course, in Sagittarius, the brightest one visible from the northern hemisphere at magnitude 5.2. Very large, 24 arc minutes in size. However, it's about a third of the distance that Messier 13 is at 10,400 light years. If you're wondering about Messier 13, it's progressed too far to the west, and I'd have to do an equatorial flip on the scope, which I'm not intending to do this evening. We're at right ascension, 18 hours and 36 minutes, 24 seconds, and minus 23 degrees, 54 minutes, 12 seconds, almost minus 24 degrees with celestial equator, and that is not a particularly bad view. We're getting some decent resolution. Lots of bright stars. I would assume that the brightest stars in this globular cluster are probably somewhere around magnitude 12. Once again, the Messier catalog data entries aren't as robust as those for NGC, and personally I have not committed the NGC number for Messier 22 or practically any of them to memory. So there's our view. We'll make a quick tour of some of the other beautiful studies associated with Sagittarius, beginning with the lagoon, Messier 8. Well, we've got a scrub on Messier 8. It's progressed too far. The scope mount wanted to do a equatorial flip, so forget that. You'll probably recognize this nebulation, Messier 17, the Swan Nebula in Sagittarius, magnitude 6, full moon size, 30 by 30 arc minutes, 5,000 light years distant. Obviously a emissive type nebula with lots of star formation, although the star formation isn't really well advanced, I believe, in this particular nebula. It's right ascension, 18 hours, 20 minutes, and 48 seconds. Declination a little further north than Messier 22 at minus 16, 11, and 0 seconds. So there's a pretty decent view. A nice kicker for the evening along with Messier 22. Let's have a look at Messier 11 if we don't do an equatorial flip. While Messier 11 may look to be the same class of study as Messier twice 11 or 22, it is actually an open cluster, although it's fairly robust and fairly tightly packed for a cluster of that type. It's magnitude 5.8, 14 arc minutes in size, so it's about half the size of Messier 22, 6,000 light years distant, about half as far as well. Right ascension 1851.06 and declination minus 06, 16 minutes and 0 seconds. We are progressing north with this view. Okay, I figure we've already observed a globular cluster Messier 22, a nebulosity Messier 17, an open cluster Messier 11. Let's have a look at a planetary nebula. Obviously one we've viewed many times before and well worth other looks. This, of course, is the Dumbbell Nebula Messier 22. Dumbbell Nebula Messier 27. It's me, I'm the dumbbell for calling it Messier 22. Right now I am trying to, okay, here we go, fumble fingering a little bit. Messier 22 is planetary nebula in Vulpecula. Magnitude 7.3, largish, 8 by 5.6 arc minutes, a mere 1,300 light years distant, which puts it at a little more than half the distance to the Ring Nebula, which, if we don't do an equatorial flip, we'll have a look at, and we'll have a chance to compare a edge-on planetary, which is the Dumbbell, who is presenting its equator towards us, as opposed to the Ring Nebula, which will be vertiginous because it's presenting its polar regions to us. Now, this isn't one of the best views we're going to get of this as we've gotten in the past, largely because we're not seeing as much color. The background sky is quite bright due to the dust and the smoke dust in the atmosphere. So it's a decent view, but not particularly striking. We have seen better views on darker nights. Earlier this summer, early July, for instance, we didn't have the fires going on, and we got some really fine views when the moon was absent. Let's have a look. Maybe we'll get a view of Messier 57, unless the scope wants to pole flip, or equatorial flip. We're a little bit fortunate this evening. We're getting a little bit of aperture block, which is quite good because these settings absorb far too much light to give a decent view of the Ring Nebula, Messier 57. So actually cutting down on the aperture, it works out quite well. So there is our view of a polar type planetary nebula presentation, because the central star, which is about magnitude 14.5, maybe a little fainter, maybe 15.1. I don't have that quite committed to memory yet. But anyway, I believe it is 15.1. And I think we're actually kind of making it out, which is quite propitious because we are getting aperture block, which means we are not overexposing at 128 flood, 42 decibels. Say hello to the Ring Nebula, but you can't put this one around anybody's finger. Okay, speaking of planetary nebula, here's another one. This one's in Aquila. As I said, I've dubbed this kind of like the old folks' home for stars, Aquila the Eagle, because there's so many planetary nebula associated with that particular constellation. No doubt it's a very old part with lots of star formation from much earlier in the galaxy's prematurity or maturity. Most planetary nebulas have a couple solar masses, and typically they last for maybe 6 or 7 billion years. So we can assume this one's near the end. It's probably about, let's just assume about half the age of our galaxy, the Milky Way, as it is. Here's a nice view. NGC 6804, planetary nebula Aquila, magnitude 12.4, 63 by 50 arc seconds. It's got the central star, which is quite visible, is magnitude 14.2, 5,600 light years distant. We're at right ascension 1931-35, and declination 9 degrees, 13 minutes, and 31 seconds. A star of magnitude 14.2 should be just detectable through an 8-inch telescope on a very good night when the study is in the sky's middle third. And it's quite visible here. I would say we can probably go at least a magnitude and maybe a magnitude and a half fainter. So right now I'd say we're probably imaging stars to magnitude 16 despite the smoke that gets in your eyes. Okay, let's watch this one develop. It's NGC 6814. Data to come. It's a little far south from what I would like to image at this point, especially because it is a galaxy. This particular galaxy, NGC 6814, is fairly large and fairly bright if we can find it on the screen. It's magnitude 11.2, but it's large, 3.5 by 3.5 arc minutes, which puts it at probably an average surface brightness somewhere around magnitude 14. Spiral with a bar, lowercase bc, so 2.5 times removed from the lenticular class of 0. This particular galaxy has a ring, and ordinarily we should be able to see the ring on a very good night. In fact, I think the galaxy is right there, and we can almost see an annulus around it. I can't confirm that right now, though. We're at right ascension 1942-40, and one of the reasons we're not getting as good a deep a view as we might want is because it's at minus 10 degrees, 19 minutes, 26 seconds in declination. So there we have it. And it does look like we are seeing a little bit of the annularity. And most annularities are about 4.5 magnitudes fainter than the collective magnitude of the galaxy itself. So that puts us at about 15.7. So yeah, it is being hinted at if we can actually see 16th magnitude stars. NGC 6814. All right, I've launched this a little early because we've kind of got a slow progressing satellite across the screen. Now remember, this width of the screen is about 15 arc minutes, so you can get an idea of how fast this thing is moving. And if anyone wants to sit down with a calculator, you could kind of guess at its distance from the Earth. As slow as it's moving, I can only speculate. If it's not something in the atmosphere and it's actually in orbit, it's got to be at least 1,000 miles out in space. And I'm not going to take the time to try to figure this out. But anyway, what we're trying to look at here is NGC 6821, Galaxy in Aquila, magnitude 13.1, 1.3 by 1.1 arc minutes. Spiral with a bar, lowercase cd, 68 million light years distant, puts it at about 40,000 light years in diameter. We're at right ascension 1944-24, minus 6 degrees, 50 minutes and 3 seconds. And I believe the galaxy is there, but it is incredibly faint. I just don't understand why it's listed as a 13.1 magnitude galaxy, especially when it's pretty close to 1 arc minute in size. Never know, there could be some transient conditions contributing to it. What we're not seeing here is Barnard's galaxy, NGC 60A22. Barnard's galaxy is larger than this screen in apparent size. So all you're going to do is get vague hints of some brightening. I have seen it at the eyepiece of a 6-inch scope at low power, and you really do want to get the magnification as low as possible to see Barnard's galaxy. It was in fact discovered at the 6-inch pointer scope. I wouldn't really call it a finder scope. I believe it's on the 100-inch Mount Wilson telescope. And by the astronomer, when I guess he was maybe setting up some photography in this region, there is a planetary nebula in this area that may have been being imaged at the time, and he saw it in the 6-inch scope while doing the images, and possibly doing some corrections to stars while the longer period exposure was being done. But anyway, there's some hints of brighter nebulosity in this region here, which could be NGC 6822, galaxy Sagittarius, magnitude 8.8, 15.4 by 14.2 arc minutes. So it's got probably an average surface brightness somewhere around magnitude 15. Irregular galaxy, 1.8 million light years distant. Right ascension 1944-56, declination 1448-23. What we're hoping to see here is NGC 6835, a galaxy in Sagittarius, magnitude 12.5. The reason I selected it is because it's 2.4 by 0.7 arc minutes, so that is clearly the galaxy. It's not quite perfectly edge on, but the aspect ratio is very close to it. If it weren't for the fact the rest of the sky is so bright around it, we'd probably get a fairly decent view. We might be rather impressed by NGC 6835, galaxy Sagittarius, magnitude 12.5, 2.4 by 0.7 arc minutes, spiral with a bar, lowercase a, 71 million light years distant, puts it probably around 50,000 light years in diameter. Right ascension 1954-32, declination pretty decent, but outside the sky's middle third, minus 12 degrees, 34 minutes, and 3 seconds. But at least this time we can really tell that we are actually imaging a galaxy. Okay, let's watch this one develop, see if you can determine what class of study it is. Of course, I have the benefit of the handset. It is an NGC. NGC 6838, very nice globular cluster. And I bet you can determine, based on its look, that even Charles Messier or associates with their 3 and 4 inch non-achromatic refractors of the late 1700s would have detected it. It is indeed Messier 71, globular cluster in Sagitta, magnitude 8.3, 6.1 arc minutes in size. Very similar in terms of magnitude and size to Messier 56. The brightest stars of Messier 71 are magnitude 12.1, which means they're about 4 magnitudes brighter than the cluster as a whole. So this is a fairly loosely constituted cluster. 12,000 light years distant. Right ascension 1953-46, declination 1846-41. Very nice look. And if you want to know what 6 arc minutes are, that's about the size. But if you go from tip to tip of my fingers, that's about 6 arc minutes in apparent size right there. So you can see many stars in that vicinity. What's formulating now is NGC 6842. A faintish planetary nebula in Vulpecula, magnitude 13.1. 53 by 48 arc seconds. Its central star is magnitude 14.5. I am getting a sense of it on the screen. You'll have to look for it yourself. It's a little off angle for me. We're at right ascension, 4,500 light years distant. We're at right ascension 19 hours, 55 minutes and 2 seconds. Declination plus 29, 17, 20. So well placed in the sky, in a star, faint star-rich region. Okay, here we have another planetary nebula in the retirement home of constellations, Aquila, NGC 6852, magnitude 11.4, 28 arc seconds in size, with a central star of magnitude 17.9. No look on that one. Planetary is right about there, I think. It must be edge-on type of the dumbbell class. Right, it just says 28 arc seconds in size, so it should be presenting spherically, but it doesn't appear to be on the screen. Right ascension 20 hours and 39 seconds, with a declination of 1 degree 43 minutes and 41 seconds. Not a spectacular look as I was hoping for when I selected it, but still, it is a planetary nebula in Aquila. Here we have another planetary nebula, NGC 6853, in Vulpecula, magnitude 7.3, 480 by 340 arc seconds in size. Central star is magnitude 14.1. It's a mere 860 light years distant, right ascension 1959-36, declination 22-43-15. Extra points for anyone out there who can also declare its Messier listing and common name. As the ghost of the dumbbell nebula leaves the screen, we're now at NGC 6857, classed purely as a nebula in Cygnus. Overall brightness is magnitude 11.4, smallish 0.8 arc minutes. It does have a star associated with it, but they didn't declare this a planetary. You can see the nebulosity right there. It is considered an emissive type nebulosity. More research could be done on NGC 6857 because it's got a rather obscure reference and not a planetary. Right ascension 20:01:48. Declination plus 33, 31, 33, well placed in the sky overhead and easily detected on the screen before you. What we have here is a nebula and open cluster in Cygnus, NGC 6871. Magnitude 5.2, 20 arc minutes in size, some 15 stars, the brightest which are magnitude 6.8. So that gives you an idea how bright a 7th magnitude star appears using real-time imaging at these settings. It's a class 4-3, which means the stars are spread out and widely disparate in magnitude. 5,100 light years distant, we're at 20:05:59, 35:46, 38. The cluster is obvious, the nebulosity is not. Okay, ordinarily I might carpe noctem out on this study. NGC 6888, nebulosity in Cygnus, magnitude 10, 20 by 10 arc minutes inside. It's an emissive type nebulosity, so it's being stimulated to an ionization state by neighboring stars, and you can see some color in it that suggests more than reflectivity. 4,800 light years distant, right ascension 20:12:06, 38:21:17, and I have viewed this and imaged this so many times. Anybody who has watched this video series should know its common name. Let's watch this one develop as I call up the data. At this point, not seeing much really on the screen. What we're looking for is NGC 6900, a galaxy in Aquila, magnitude 14, 1 by 0.8 arc minutes, spiral, 2 times removed from lenticular, so it's class B, 230 million light years distant. It's at right ascension 20, 21, 35, minus 2, 34, 12. And I will tell you that my experience with smoky skies has basically indicated to me that they have their greatest effect on observing on galaxies. They just cause such a loss of contrast that it's very difficult to pick out galaxies on the screen. Even as bright as magnitude 13.1, we've been having a bit of a challenge. I do believe the galaxy is right about there, however. So I would say the impact of smoke and ash in the air, maybe not ash, I don't think we're experiencing much in the way of ash. It falls to the earth. I haven't seen any collected on the grass. But anyway, smoke and dust in the air is very negative in its impact on galaxies. Well, this should be our Carpe Noctem view of the evening. I'm hoping it's a good enough view that you will want to come back for more. This is probably my 150th real-time imaging session over the last, I believe I started in January 2022. We're now midsummer of 2024. And over the time, I've had to spend a good deal of time experimenting, setting the scope up, experimenting with settings, mounting things in more improved ways, trying to improve the image. It's been quite a learning experience, and I've really enjoyed it. So NGC 6905 is a planetary nebula in Delphinish, the dolphin. Magnitude 12, 44 by 38 arc seconds. We definitely get a really nice sense of a frontier. Its central star is magnitude 14, and you can see it there, but it's kind of offset. That's an intriguing characteristic of this planetary nebula. 5,700 light years distant, right ascension 2022, 23, declination 2006, 16, and I'm about to use this planetary for an experiment because I think the screen is too bright, and I've already run down the brightness setting on the screen to brightness level 5. Now there's another set of parameters I can play with, and I'm going to do that now, and then we're going to have another look at NGC 6905 with the new settings with a slightly darker background sky. Although I can make adjustments when I actually pull together the images. I'd rather have something that looks a little more attractive natively in the camera. So let me go ahead and play with the brightness parameter, which is actually associated with the CCD imager, the Rev2 CCD imager. And we'll be right back. Okay, I've just run the brightness all the way back to 0. Nice dark image, but no view of the planetary. Started at about 1:30. I'm going to push it up to where it looks nice to me. I'm going to stop at 50, and we'll see what happens as it develops. Still looks like more like an eyepiece view to me. Very nice. The planetary is just beginning to reveal itself. Let's push it up to 75 and leave it, and then I'll adjust the brightness on the actual screen itself. Okay, I'm going to save this out and save. Okay, so there we go. Screen looks significantly darker. There's a little bit of a contrast bar in the lower part, but not really obvious. Planetary looks pretty nice up there. So what I'm going to do is maybe review, no, we'll leave it for another night. So have a good look at the previous view of this planetary nebula, NGC 6905. Magnitude 12, 44 by 38 arc seconds with a 14th magnitude central star, which is quite obvious, I like the aesthetics of this view, and I just can't help but want to look at a 14th magnitude or galaxy and see if it pops a little better. How about you? Yeah, let's see if I can trace back to one of the earlier galaxies that we've already had a look at for comparo. Okay, let's watch NGC 6900, a galaxy in Aquila, develop on the screen. Okay, NGC 6900 is a galaxy in Aquila, magnitude 14, 1 by 0.8 arc minutes, spiral with a bar 230 million light years distant, right ascension 2020 135, declination minus O2 3412. Now, are we making it out any better? Well, maybe. Let's go look at the crescent again. And now we're going to have a look at NGC 6888. Give it the requisite 35-40 seconds to develop on the screen. It's a nebula in Cygnus, magnitude 10, 20 by 10 arc minutes, emissive type 4,800 light years distant, right ascension 2012-06, declination 38-21-17. Well, I think we're actually maybe making a little bit more texture now that I've run the screen brightness down. Now, ordinarily the screen brightness wouldn't have been as overpowering as it appears. The problem is largely the smoke in the atmosphere and the lights, but still, I'm liking this, and when we go back to resuming other studies with the sky a little bit clearer, it'll be interesting to see what we turn up. Of course, there's one other study we want to observe before we end up bailing for the evening. This will be our Carpe Nocte view of Messier 27 this evening. The Dumbbell Nebula, Messier 27 in Vulpecula. Planetary type, CNED John. Magnitude 7.3, 8 by 5.6 arc minutes, 1,300 light years distant, 1959-36 right ascension, declination plus 22-43-16. And what we want to look for here is a little more variation in color. We also want to make sure we get a good sense of the frontier going to the 2 and 7 o'clock positions. That central star is magnitude 14.1. Certainly, the aesthetics of the view has been significantly improved by reducing the screen brightness. But that's here in real time. I have no idea the way it's going to appear when I process it using Windows Movie Maker. So let's give it a few more seconds before we sign off by saying Carpe.